Okay, early morning hustle. Yes, you can do it. One sample proportion inference. Why don't you go ahead and read the description? Look at the numbers within the summary statistics. Look at the visualization. What type of visualization is it? Then finally just go over the analysis and then come back. Welcome back. We're doing one sample proportion inference. Let's talk about this problem. The Portland Parks Department is investigating usage of their new bike sharing program. They got some money. They're trying to implement some more bike sharing things. And let's see, are people listening? Are people working with this new program? From the registered user base of 12,000 people. That's the population. They randomly sampled 300 users. Wow, that's a sample. And they found 195 had used the bike sharing service at least once in the past month. Okay, so here in the situation, either you used it at least once or you did not use it at least once. Okay, the department wants to determine the usage rate. Did they give us a claim? No. Did they give us a hypothesis? No. They just said, I want to know the rate. Okay, so that bleeds, that tells you, it gives you some extra information on what we're going to be doing here. So here we have the summary statistics. We have 195 active users and 105 inactive users. Okay, we can actually visualize this using a what? A bar plot. Bar graph, that's fine. I say bar plot. Okay, it's a bar plot. Okay, so we're looking at the frequency of active users and the frequency of inactive users using bars. Obviously, there's more individuals actually that are active users. Fantastic. We can now go down to the analysis. In this analysis, I'm providing you the number of successes. In this situation, 195. I'm also providing the sample, 300. The sample proportion, 195 divided by 300. That's not quite correct. My apologies for that. The test statistic, which is going to be not necessarily used here, the standard error for confidence intervals. The confidence level, because it wasn't specified, so we're going to automatically assume 0.95. And then the critical value, okay, that comes from the confidence level. And then finally, the lower bound and upper bound. Lower bound and upper bound. All right, so with that being said, go ahead and take a moment and answer some of the questions before I do. Okay, I'm going to start answering some of the questions. So why does this research matter in real world terms? So you can imagine if you implement this program or you've received money to implement this program, the stakeholders, those that gave you the money, want to know if it's being actually used. So we don't necessarily know or have some idea of what that rate or percentage is, but we can figure out with some confidence what that rate is regarding the population if we were to just take a sample. Okay? So here in this situation, the actual importance is to know if this actual program is being used by our constituents, okay, by our users, okay, and are we actually putting our tax money to good use? With that being said, what's being measured on each of those users? Okay, what's being measured is whether they use the program at least once in the past month or not. Okay, either they did or they did not. So that's going to be our variable of interest, and it's going to make it categorical binary because it's either you do or you don't. What's the observational unit? It's going to be a registered user. Okay. What makes up the population? It's going to be those 12,000 registered users in Portland. Okay. Portland, Oregon, to be more exact. How did we select the sample? We randomly selected the 300 individuals. Okay. And then from there, did we manipulate anyone? Did anyone receive some type of treatment? No. So that's what makes this an observational study. And we know for a fact that we are looking at a one sample proportion inference, but are we interested in a confidence interval or a hypothesis test? If we look closely, we're just trying to determine the usage rate. We have no claim. We have no hypothesis, which makes this particular technique a confidence interval. Okay, a confidence interval. All right. So that being the case, why don't you pause, really pause, and do question 8. So when it comes to question 8, if you don't, of course, you don't have these little prompts, but by the 5th or 6th video, you should start developing a framework. But the first thing I would want to do is state the parameter of interest. The parameter of interest is going to be what? It's going to be a population proportion, because we're done with proportions. A proportion of users, of registered users that actually use the service at least once in the past month. Okay, so it's going to be the population proportion. At the same time, we have to estimate it because we don't have access to each and every user, registered user, so we have to get a sample, okay? And that point estimate is from the sample, and that's going to be used to estimate the actual population proportion, okay? So it's going to be P hat is going to estimate P. P hat is going to estimate P. So let me emphasize this even more. The parameter of interest, the population proportion P, is being estimated by P hat 195x divided by n 300, which gives us 0.65. Another way of saying the point estimate, which is being used to estimate P, is going to be, or which is the sample statistic, okay? More specifically, the sample proportion. All right? So with that being said, what are the assumptions? Importantly, we need to make sure that it's random. We need to have a random sample. It is what it is. It needs to be random. Because if it's not random, we're not necessarily getting a representative representation of the population. So therefore, our inference is going to be, we shouldn't trust it. We should not trust our inference if it's a non-random sample. And last but not least, we need to have a symmetric distribution of our data. So we need to make sure that n times p hat and n times q hat, where q hat is 1 minus p hat, is greater than 10, so that our distribution is symmetric. Okay, it's one in unimodal. 195 and 105, they're both greater than 10. Good to go. Good to go. Now we can do some calculations. We can now find our margin of error, right, by taking the critical value and multiplying it by the standard error. I'm going to first talk about the standard error. How do we find it? This is the equation. The square root of p hat times q hat over n, where p hat is 0.65 and q hat, is 0.35. And then divided by 300. Square root of that gives us 0.275, which is this number here. And then in order for us to find our critical value, since we didn't mention anything about the distribution, we're automatically going to use a 95% confidence interval from the normal distribution because we're dealing with proportions. We're always going to use the normal distribution when dealing with proportions, okay? And so since we're doing a 95% confidence interval, our critical value is 1.96. 1.96. So then finally, our margin of error is 0.0539. We can then use this number to find our lower bound and upper bound. Okay, our equation for finding the lower bound and upper bound can be seen as such: point estimate plus or minus the margin of error. This could also be re-expressed as the point estimate plus or minus the critical value times standard error. And so then here, in terms of our numbers, we're going to have 0.65 plus or minus 0.0539. Our lower bound is going to be 0.65 minus 0.05. And then our upper bound is going to be 0.65 plus 0.0539. Okay? And so, provide a description. We are 95% confident that the population proportion of registered bike users in Portland, Oregon is that use the bike service within at least once in the last month is in between this proportion. But why is that important? Who really cares? Can you imagine if there's another grant for the following year saying that if you have 50% of your sample of your population actually use this feature, this new program will give you more money? Well, gosh darn almighty, you can tell them that we got in between 59% to 73%. We're 95% confident that the proportion of those that live in this community, 12,000, population proportion, is in between 59 and 70%. We're doing good. Give us more money. All right. So this is you utilizing evidence to make a claim. Okay. That the actual program works. So thank you for watching. Early Morning Hustle. You can do it. And that's it for today's video.